that you've probably heard a lot about cryptographic hashes. They're known as the workhorse behind blockchain because a lot of the reasons why blockchain is able to preserve the integrity of data is due to cryptographic hashes. I'm George Levy, and in this video, I'm going to be talking to you about cryptographic hashes, but we're going to have a lot of fun with them. We're actually going to be focusing on SHA-256, which is a type of cryptographic hash that's used extensively in Bitcoin and in many other cryptocurrencies. Now, for this video, we're actually going to be looking at different ways of generating cryptographic hashes, and we're going to be using online generators that you can play with, and also I'll teach you how you can generate your own cryptographic hashes using Python programming. I encourage you while you're here to subscribe to this channel, as every single week I publish brand new videos. And while you're here, also visit georgelevy.com/free to sign up and receive free lessons from my paid courses. Now, we have a lot of stuff to cover, so let's do this. In this video, we will be talking about cryptographic hashes, and one of the things about cryptographic hashes is that they are known as the workhorse behind blockchain technology. They're actually one of the key ways that the blockchain is able to preserve the integrity of the information that's recorded on blockchain. And I'll tell you exactly how it works in this video. So to do so, I want to start with a cryptographic hash generator found at demoblockchain.org/hash. Now, this specific hash generator that we're going to use is going to be using a type of cryptographic hash algorithm called SHA-256. And there are many other cryptographic hashes, but for this example, we'll use SHA-256, which happens to be the cryptographic hash algorithm that's mostly used in Bitcoin. So for this example, I want to show you exactly what a cryptographic hash is, specifically a SHA-256 hash. This is a cryptographic hash generator that generates SHA-256 hashes. So let's just go ahead and type something in here. For example, dog. What you will find is that as I type in the word dog, this field at the bottom that says hash changes. So you see right now that we have a cryptographic hash that begins with 0EB and ends in D88. Now notice, if I do anything to change the data here, say for example add a period, you will find that the cryptographic hash changes at the bottom. Now it begins with 5B8 and ends in 42D. Now, what changed is that we changed the digital signature for that specific data we put in. We're no longer writing dog without a period. Now it's dog with a period. You see, what we're doing is we're taking whatever data is in this field and we're creating a digital fingerprint for it. This is actually a message digest of this data we're placing here. Let's go back to dog without a period. You'll find that right now what we have is we have the same exact cryptographic hash, 0EB, and ends in D88. Now this is what's interesting. If I were to change, for example, the D and put a lowercase d, it's a completely different word, right? It's a different amount of data. It's not even the word, because this could be just random data. It doesn't matter. The cryptographic hash will be generated for whatever's in here. It doesn't have to be dog. But let's go back to dog and put a capital. And you find that we have exactly the same cryptographic hash we had from before. Now notice what's cool about this. In this process, this cryptographic hash we're seeing here is exactly the same length. This is a fixed size alphanumeric string. And it doesn't matter how much data I put in here, you will still generate a fixed size alphanumeric string of whatever data is in here. Let's have some fun with this thing. Let me take you back to dog. And we have the same exact digital fingerprint, 0EB, and ends on D88. And let's have fun with this. Let's just go ahead and go to Moby Dick. This is a massive body of work. And I'm not going to paste the whole thing, but I could. In fact, I could take every single book ever created in the history of mankind and take the text and place it and generate a SHA-256. But let's have some fun with this. Let's go ahead and take the last chapter. And I'm going to just go ahead and copy. Let's just go down to the bottom, all the way to here. This is a great story. I'm going to go ahead and copy it. And I'm going to go to the cryptographic hash generator, and I am going to paste this. And notice I have just created a cryptographic hash, a SHA-256 hash to be exact, of all that text. And it's the same exact length as the text we had before. Now let's have fun with this. You notice that this one begins with 2C9 and ends in 944E. Let's go ahead and take off all of this and go back to typing in DOG. And what do we get? The same exact cryptographic hash that we had before, ending in D88. And let's have fun with this again. Let's paste everything we had before. And you find that we have exactly the same cryptographic hash we did before. That SHA-256 digital fingerprint is the same. Now, many people think that, well, I mean, this is just text. It's not really data. Okay, let's have some fun with this. And for this, we're going to go ahead and go to an online hash generator that lets you play with files. Now, this is what's cool about it. You don't need to get a cryptographic hash for just some text. You can actually hash a file, whether it's an application or an MP3 or a photo, or actually, let's do a photo. So we're going to create a SHA-256, and I'm going to go ahead and choose a file. And I have this specific photo, George-Levy _blockchain.png. Now, I'm going to be using this file again as we go on with this lesson, but check this out. As I go through this process, I'm going to go ahead and take that specific file and input it into the hash generator we got. And what do we get? We have a SHA-256 hash for this photo file. It begins with 936D, that's 936D, and ends in F7DF. This is going to be very valuable as we go on with this lesson because we're going to have fun with this. Right now we'll be using online hash generators, but how about we do some local code and let's play with Python. Let's go there. Okay, great. Now that we've had some fun online, we actually generated cryptographic hashes. We saw that each cryptographic hash is actually a message digest or digital fingerprint of a file. Let's have some fun with code. And I'm going to play with some Python right now. We're going to generate that SHA-256 of that file that we actually tried online so we can actually do it ourselves. Follow along if you actually have any background in Python. I'm going to be using Python. It's going to be a relatively easy program for you to work with, but it's going to be really cool. We're going to generate a SHA-256 generator that we're going to run locally here. And you're going to see that we're going to get exactly the same results. And then we're going to have some fun playing with these cryptographic hashes. So to start, the first thing I want to show you is that I've actually generated I've actually created a folder. And in that specific folder, I have a file, exactly the same file that we generated the cryptographic hash online. And we're going to play with it so you can see we get exactly the same result. The whole point is you will always get the same cryptographic hash for a file no matter where you use SHA-256. So we're going to actually do that same exact SHA-256 hash of this George Levy blockchain file, but we're going to do it locally using Python. And to do that, let's just go ahead and pop open Python. I'm going to pop open the shell and let's create a new file. The main thing I want to do is I want to create this file. Let me just go ahead and save it on exactly the same folder that we've been working on because it's going to make things a lot easier. And let's give a name to this. It's going to be SHA-256 generator. And actually, let's just go ahead and code it in a way that we can use it for any file, not just this specific picture. So let's go ahead and generate that. The first thing we need to do is import the Hashlib module from the Python standard library. And this is important because Python has what's known as batteries included, which means that there's a lot of functionality already built into the Python standard library, which you can just import and use. So let's go ahead and import that module right now. That module is called Hashlib. So we're going to import that and let's create our first variable. This variable is going to be file name, and let's do an input so we can actually get the name for that specific file that we're going to be accessing. So what is the name of the file? Let me go ahead and I'm going to close that out and let's build in the functionality. We're going to head and open that variable, and let me set some of the main specifics on this. And as we work through this process, one of the things that you're going to see is that I am going to make this as generic as possible so that we can actually do this with any other file, not just this one graphic that we're using. We could actually do this with any other file. It could be a text file. It could be an application, like a file of a program. It could be an MP3. Any type of file you can run through a SHA-256 generator. So in this case, okay, so we're going to read this as bytes. So let's define that right now. So f.read, and go ahead and set this up specifically. Now we're going to make this a readable hash variable. This is going to be a new variable, and that variable is going to be the hash library. Right here is where we're going to define that it's a SHA-256. As I mentioned, Python has batteries included, and this is where you're going to see right here. I am already importing that SHA-256 hash generator. So let's go ahead and call out bytes, and let's make a hexadecimal digest in this case. So let me make sure I got this in straight, and as we go, let me just print it out so we actually get the full value of what we're getting. We're going to call out that variable we generated, the readable hash, and Let me look through my code, make sure that I don't have any bugs right now because we're flying without a net. And import Hashlib. I got my file name. I've got the input of the file. Actually, just because it's prettier, let me just put a question mark. You don't really need this, but I just put it because I like it. And let's just go ahead. We got all the code, and the main thing we're going to do is right now let's save it, and let's run this puppy, see what happens. So we're going to pop open the shell. This specific shell is going to then ask us for the name of the file. Let's go to the file we got, and let's get the name of that file. So I'm just going to go ahead and get it, including the PNG. And I'm just going to go hop in here, pop it in, and let it do its magic. And what you see is we get exactly the same cryptographic hash we had before. Now, you want to have fun? Check this out. If you go over here, and let's go back to the same folder that we were, and let's play with this so you see the beauty of having a cryptographic hash generator and being able to generate a SHA-256 hash for any type of file. Let's go ahead and do this. Let's copy this specific file, and we made a copy right here. Now here's what's cool. You have two files, right? But we know it's the same exact picture. So let's see what the SHA-256 generator thinks. Now notice, I've already changed the file name, not the file name. Let me go ahead and copy that. And let me get it including the PNG. So notice we're going to right now generate the SHA-256 for this copy. So let's just go ahead and run this again. And it's going to ask me for the name of the file. And now we are going to generate a SHA-256 for the copy. And voila, you have exactly the same exact SHA-256. And this proves to you that generating a SHA-256 hash of any file will give you the integrity of the file. And as long as you could change the name as many times as you want, but as long as the file is exactly the same file, you will always get a SHA-256 hash that will be exactly the same.
I hope you enjoyed this video and that you learned something in the process. I bring you brand new videos every single week, so I invite you also to subscribe so we can stay in touch. Also, if you have any comments or suggestions, please leave them below. I would love to hear from you. Until next time, we are changing the world, one blockchain at a time. I'm George Levy. Thank you for watching.